I don't have to worry about the tree, because they can get wet. Because they've evolved in the presence of wet. Now here's the funny thing. Starting in the late 1800s, our idea of protecting forests was to prevent wildfires. It turns out that was one of the stupidest, most expensive mistakes in the history of this country. For more than 100 years, we will be wasting, listen carefully, hundreds of billions of dollars, with a B. Billions and billions, hundreds of billions of dollars, because we just blew it. We shouldn't have put out the fires. Here comes the explanation. In nature, fire renewal communities don't usually get big old massive gnarly fires. Anybody remember all of our recent fires in Santa Barbara? The Gap, the Jesuita, and the Tea Fire? There was the Zaca in the background too. All four of those were giant fires that burned extremely hot, cost millions of dollars. They all caused loss of life, I think.
Not Zaca.
Maybe not the Zaca. Firefighters?
Not being a firefighter.
2 firefighters? Okay, maybe I'm wrong about that. Anyway, giant fires, very expensive, very dangerous. That shouldn't have happened. There was too much fuel because we prevented fires in the past. Watch what happens in a natural fire renewal community like this. You get this thing called patchiness. And here comes a very technical explanation. The forest is in patches. Now, patchiness prevents big fires. So patchiness continues to make patchiness. And I'll clarify what I mean. But patchiness is a positive feedback to maintain patchiness too. I'll clarify this. Please look up here. In this forest, those different numbers tell you how long it's been since the last fire. This area burned this year, this burned last year, those burned 2 years ago, those burned 7 years ago, that one burned 10 years ago. So of course, you understand ecological succession. Remember, this will be just ashes, this will be weeds, this will have a couple of weeds accumulating on top of the other weeds. This is starting to see the natives move in. This is a lot more natives moving in. Everybody understand that? Early in succession, you don't have a lot of accumulation of fuel. There's not a lot of wood yet. All you have is green tissues. So watch what happens. If lightning strikes, goes zap, and makes a fire, that fire is not going to spread. Please look up. If I light this spot on fire, that'll burn. But you can't burn ashes. And when you start to burn like grasses and lightweight green material, the fire basically fizzles out. It's too wet. It can burn a bunch of green plants and it goes, and makes the steam and then it's over. You see, a fire here will be small, relatively cool, doesn't get like a ton of fuel to get a ton of heat. And that means it'll recover quickly because all the neighbors will donate seeds. The wildlife will spread from the patches that didn't burn. And by having patchiness, you just make another little patch with each fire. Compare that to the Santa Barbara foothills. No patches. 10 years ago, the average acre of Los Padres National Forest had not seen fire in 65 years. Which means you had 65 years of dead organic material waiting to catch on fire. You hit that with a single spark, and there's nothing to slow you down. The momentum builds, the amount of heat cannot escape into atmosphere quickly enough. So the heat rises and rises. You get giant, deadlier, more expensive, hotter fires. And here's the key issue. Please look up, even if the bell rings, stay and wait. Slower succession. Because the heat kills the seeds in the soil, and the size means you're very far away from seed sources and wildlife sources. We are now damned if we do and damned if we don't. Because if we let this burn, the fires get raging, expensive, deadly, out of control, ecologically very damaging. In places where we've ever prevented fires, fires are less of a problem. Here, fires are small, even when they recover quickly. Nobody gives a crap. How do we get this landscape back to patches? Yeah, we have to do two options. They're both ways to reintroduce patchiness. One of them is thinning. Get rid of the fuel. Use like a weed whacker and a big chipper and shred up all the fuel. The other one is controlled burns, which in this sort of a landscape is really effing dicey. But the point is, one way or another, we have to reintroduce patchiness.
Is the reason that all the fuel matter is because the landscape evolves patchiness, so
Yeah. Well,
because I know
these are arid environments. Fire renewal communities are by definition arid. So you don't have the water that helps you do the magic mojo. In a climate that's wet enough, decomposition literally flies your forest. So as long as you add water, nutrient cycling kind of happens on its own, and that biomass will be returned into the ground. But in really arid landscapes, you have limited mojo, you have limited nutrient content. Yeah. It's not like the whole system has evolved like that strategy. It's that the system has evolved due to the weather being more arid. It's another way to get your nutrients right. All right. I'd like to do one thing, please. Because I thought we were in a hurry because you were all packing, but you were all cheating me out of my minutes. Yeah, I know, we're all confused. Back to me, though. Watch me. Watch this. I'm going to make a single sentence that puts this all together. Watch. Fire suppression in fire renewal communities leads an unnatural abundance of fuel, which makes fires bigger, more expensive and deadlier, and worst of all, hotter. And this combination of factors slows recovery, so ecologically it's bad too. If you understood all of that, you're ready. Good? But